In our second chapter of Volume 1, we go over the operations and properties of real numbers. What we're trying to do is, at the end of this chapter, is teach you how to collect like terms. Then we're also going over how to simplify expressions that look like this. When we're collecting like terms, what we need to do is get the x's together and the x squares together. We will go over in this chapter the various properties that allow us to do this. The property that allows us to switch the order around is called the commutative property. Then once we have the order switched around, we will want to factor out the x and then factor out the x squared. Then once we have factored out the x and the x squared, we can use our rules for addition and subtraction to simplify the problem. When we're removing grouping symbols, we like to, if necessary, insert a 1 or a -1 in front of the grouping symbol. We like to use the expand mnemonic to remove the grouping symbol. If possible, collect like terms and repeat the process for each grouping symbol. Now, once we start using these processes over here, in the first one where we were showing collect like terms, we actually showed the commutative property and the distributive property being worked out. Once we get down to simplifying, we will just automate these steps. So in this particular problem, we end up replacing in front of this grouping symbol with a -1. Then as we go through this chapter, we're going to teach you a way to do calculations that involves mentally doing the calculations where you don't have to put in all the extra double signs. Again, if you prefer to put in the double signs and work them that way, that is fine. But we find that it's simpler to just work the problem out mentally. The trick to doing this mental working out of the problem is when it says subtract, we can think of this as being negative. So we take -1 times a +3 and ends up being a -3, which we write as subtract. We take -1 times a +4, which ends up being -4, which we write as subtract. We take -1 times a +20, which ends up being -20, which we write as subtract. Then, moving the like terms around, we combine the 2x and the -4x. We like to combine these by using money. So if we have $2 and a bill comes in for $4, we end up owing $2. And the other ones we put in order. So we write the -20y and write the constant last. Now, our CAS version of our calculator allows us to do these calculations. So if I flip to the next page, we can see that if we put the expression into our calculator, it will automatically give us 6x squared plus 7x. And if we put the grouping symbol in by using nested parentheses, the calculator does not use brackets and braces, so we have to use nested parentheses. It again will write the answer out for us. Again, if you wanted to see it using the emulator of the calculator, we can see it worked out here. We're now going to flip our emulator so that we only see the handheld. And as you can see, in the display is the answers that we've seen off to the side. What we need to do now is go back to the beginning of this chapter and explain how we can do these calculations mentally. So I will go to the table of contents and I will switch it to addition and subtraction of real numbers. Now, based on your ebook reader and based on which device you're looking at, the table of contents varies. When we first start off with positive and negative numbers, we look at 1.5 plus a negative 2.5. So we're starting off and showing them both written on the number line. If we put them together, connecting the vector and drawing these as a vector where we show direction and magnitude, we go out this direction and come back, we can see that the answer turns out to be -1. This is an exercise that you can do for yourself if you would like to do some more experimentation with this. On the next page, we look at subtraction. Now, to do subtraction, again, we show the 1 3/4, and then we show the -2 1/4. So the normal way that people do subtraction is they change it to addition of the opposite. So we go out this far, we take our -2 1/4 and take the opposite of it, and putting these two together, we come out to be 4. So what we have is the rules for addition of two real numbers. So again, you can take a look at the book and take a look at these particular rules. The main thing that we have to deal with is, if we're doing it formally, is when we come up with subtraction, we switch it to addition of the opposite. The next thing we're going to do is look at another TI activity. If you follow these links, you can actually download the activity and add it to your calculator. So we're going to take a look at what TI calls a hot air balloon. It's more like a gas balloon. So what we're going to have is we're going to add helium to raise the balloon. Okay, and if it's a negative number, remove helium, okay, to lower the balloon. We're going to use a positive and negative on the sand, okay. So if we add sand, we're going to lower the balloon, and if we take away sand, we're going to raise the balloon. So this is shown on our calculator, and what we see is that the subtraction of a negative is the same as the addition of a positive. They came up with the same answer. And you can think of this balloon as sitting like in a canyon and going down in the canyon and coming up. So this is the traditional change subtraction to addition of the opposite. The next thing, though, we're going to look at is kind of strange. We're going to take an addition problem and change it to subtraction of the opposite. Now, the advantage to doing this is the more complex problem then appears as the traditional subtraction problem. Putting these two pieces of information together, what we have is, if we have two like signs, -2 minus a -5, or unlike signs, we can come up with an alternate approach to change this two negative signs to a positive, and a positive and negative sign to a negative. Now, this is going to turn out to be the same mnemonic that we use when we multiply and divide positive and negative numbers. And once we get it down to the simplified form, we can use another mnemonic of working these problems out as it relates to money. So we can work this out as owe $2, $5 come in. Okay, so the result would be 3. Have $5, then owe $2, so again the result would be 3. So the mnemonic that we're talking about again is two unlike signs become a positive sign, add, and two unlike signs become a negative sign, subtract. So what we're going to deal with then is working problems out directly in simplified form instead of making them be more complex. So if we have $3 and we get $4 more, we end up with 7, traditional addition. If we owe $2, we have $5 come in, we pay off our bill, we then are left over with 3. Traditional subtraction, again, you can think of this as $5, a bill comes in for 2, so we have 3. We have $3, a bill comes in for $4, so therefore we owe 1. We owe 3, another bill comes in for 4, so we owe -7. So what we like to do, as we showed you at the beginning of this video, with collecting like terms and removing parentheses and brackets and braces, we like to keep things simpler and not add the additional double signs, which is the traditional technique of changing subtraction to addition of the opposite. And again, we like to relate this to money, which everybody can relate to. We have flipped ahead several pages in our second chapter. So we are now looking at multiplication and division of real numbers. If the two signs are alike, the result is positive. If the two signs are unlike, the result is negative. To show why this rule works, in our ebook, we go over several examples. Rather than using patterns, we use the various properties, again, which are discussed in this second chapter, to verify that why these work. So we use the distributive property to show why a negative times a negative must turn out to be a positive, which is a more formal approach than using patterns. We can see on our scratchpad screen that when they're both positives, we multiply the number and end up with a positive answer. When one of the factors is negative, we multiply the absolute value of the numbers and end up with a negative answer. And when both the answers are negative, we end up with a positive answer. Again, we really do not want to be using our calculator to do this kind of work. We need to be able to do this work manually. Division is a little bit more complex because of 0 being involved. So again, in the book, we take all these situations into account and give you an explanation for why the answers are written out. Again, two positives will end up being a positive and a negative will be a negative and a positive will be a negative, and a negative 12 times a negative 3. Well, let's go over and take a look at this on our calculator. So if we click on the scratch pad and we put in negative 12 divided by negative 3, we see that the answer turns out to be positive 4, and it switches it over to the fractional form, even though we input it in a single entry line. Now, where we start running into problems is with 0. So if we take 11 and divide it by 0, and divide by 0, it's easiest just to enter it direct. We see it's undefined. If we take 0 and we divide it by 3, we see the answer is 0. And if we take 0 and divide it by 0, we see the answer again turns out to be undefined. Now, we like to look at this slightly different than our calculator did. And again, in this chapter, we explain this. So we have the traditional problems that parallel the multiplication. We have the undefined with division by 0, with the number in the top being non-zero. We have 0 divided by a non-zero number being 0. but we like to call 0 divided by 0 more formally as indeterminate rather than undefined. Moving ahead in the chapter, we now look at some properties of fractions. And here, a negative in the front, a negative in the top, a negative in the bottom are all equivalent. Here we can simplify something by taking a number over itself out. If the common denominator is the same for both parts of a fraction, we can add it. Instead of finding the lowest common denominator, we can just multiply the two and then do the cross product in here. Again, when you're dealing with positive and negative numbers, you're going to have to watch out for the order that you do these. When we multiply fractions, we're just going to be multiplying the numerator and multiplying the denominator. And here is our traditional invert and multiply when we end up with division. Our calculator will always take answers like 6 over 10 and reduce them to 3/5. But to show that this is true, we can put them in with an equal sign and it will give us true. Again, when we take 3 times 2 over 5 times 2, we cannot switch this up to 6/10. It will just tell us the answer is 3/5. And when we end up having negative 2 over 5 or 2 over negative 5, it will say that this is true. If we attempt to do a problem with variables and we're on the numeric, the non-CAS version of the calculator, we will get an error, variable is not defined. So if I go over to my calculator and if I want to clear out my scratch pad, if I hit menu, action, 1, okay, 5, clear history, it will clear out the work area. So I can put some of this stuff in so you can see what's going on. Again, instead of putting these things in directly, we can use the division template, the fraction template for divide. So we can hit the control and the template, and we can put in 3 and then move down to 5, move over, hit equals, use the fraction template, put in 6, move down, put in 10, and see that this is true. So since this is a CAS model, if I attempt to put this into my calculator, so I'll use the fraction template and I'll put in minus A over B equals, move over, press equal, and then A over a negative B, fraction template, okay, A, move down, the opposite of B, press enter, it will say true. But again, if I attempted to do this on the numeric, the non-CAS model, it will give me this error message. We might also see what happens when we put in just the negative sign. So if I put in, okay, fraction template, and I put in negative 2, put a 5 in the bottom, and press enter, notice it converted even the input where I put it in the bottom over to a negative in the top. It will not write the negative in the front like most math textbooks like to do. When we start dealing with complex fractions or compound fractions, things get to be tricky and the precedent rule takes over. So again, let's go ahead and do the division problems on our calculator. So we'll hit menu, 1 for actions, 5 for clear the history, and we'll put in, using our template, control, 3/5, 3, down to 5, move over, hit divide. Notice it switched it over to a fraction sign, and we want to divide by 7/2, so we'll use our template again. 7/2, 7, divide by 2, press enter, and we see that the answer turns out to be 6 35ths. Again, we could put this whole problem in directly using our fraction template in there. But again, you have to be careful, because when you look at us putting in this problem in, this one looks like it's correct, but the longer fraction symbol is underneath the 7 rather than between the two. So again, be careful when you start doing these kind of problems. Best to do the fraction template and use the divide, and then let it switch it over to a compound fraction inside of a fraction. Another problem we have with our calculator is it doesn't know whether to leave the answer with terms or to switch the answer over to what looks kind of like factors. So to force it to do the answer the way that we would like, we will have to use the common denominator operation, because otherwise it won't change the answer. Again, this will only work on the CAS model. So again, let's take a look at it on our calculator. So again, let's clear out what we have, 1 and 5. So you almost, again, some of these commands are found in 2 different places, and they're found under different expressions. So if we go to menu, and if we go to number, and if we go to, number tools, nope, that wasn't where it was. If we go to number and go to fraction tools, we can see that we can find common denominator there. So then if we input in control and A over B plus control and C over D and press enter, we can see that we can come up with the answer. We could also find this under menu, algebra, fraction tools, and common denominator. So some of these things are located in a couple different places, and you're going to have to experiment a little bit to see where they're at. Let's clear this second one out because we don't need it. Let's take a look at one more thing that can happen to us with compound fractions. So if we enter this into our scratch pad, we see that the answer is AD over BC, but there's a warning, and the warning is the domain of the result might be larger than the domain of the input. And what happens is if we put the problem 3/7 divided by 5 over 0 into our calculator, it will tell us the answer is 0, because what it did was it used the simplified form to substitute in. So we again have to watch out when it has a warning. So when we actually work the problem out, we will get an erroneous answer. Okay, that's going to end our little illustration for chapter 2.